Given a string S, find the longest palindromic substring within S. In this example, ABAB is inputted, and out we would have BAB. So let's get started. For my approach, I'm going to use a dictionary, input all possible strings going forwards into the dictionary, and then analyze if those strings in reverse match any keys in the dictionary, check if it's the longest, and go from there. So let me get started. Into our dictionary, we're going to put strings, and if we see that string, we're going to increment the value. If we see that key, we'll increment the value. So that value will be integer. We'll call it dict. We'll initialize two strings, current and maxPal for maximum palindrome. We'll initialize both of these to be AB. Now, let's loop forwards for every string. So we're starting at the leftmost element. Let's open the bracket there. We'll assign the ith char of this string to be current. So current will have one letter. And it's gotta be a string, because current is of type string. J is I+1. Increment J. So here's where we're going to start tacking on to current. So current plus equals the jth element of my string and we'll check if it's already in the dictionary. If it's already in the dictionary, we'll increment 1 to the value. Else, we'll add it. And we're done with that for loop. And we're done with this for loop. Okay, so now what we have in our dictionary is, at worst case, we have n squared elements in our dictionary. So we're taking up big O of n squared space. We'll start our for loop that will go backwards through everything. So starting at the rightmost element until 0, decrement I. Initialize current to be the ith element. Okay, so J starts at the second from the rightmost element. We'll tack on to current. So we'll check a few things. We'll check if the dictionary contains the key for current. Which means that the element that went in the forwards direction, the string that went in the forwards direction, matches this string that's being built in the reverse direction. So if they match, and we're searching for the longest palindromic substring in S, so we have to check about length. The length of current is greater than or equal to the length of max pal. And the first element of current matches with the last element of current. Close off that if. So if all those things are true, then we need to update max pal because we've just found a longer palindrome. Close off this for loop. Okay, so now we have everything we need to give our answer here. If maxpel has remained unchanged, we initialize it to AB, remember. We will write out the first element of my string, because a single element can be a palindrome. Else, we'll write out maxpel. Okay. So, let's walk through this sample input and see if we can achieve this sample output. Okay, let me see how much space there is. Perfect. So we have our dictionary with our keys and our values. We'll set that up. So let's go through here. I is 0, first element in my string, the 0th element is A. Okay, so now current is A. Starting at I plus 1, current plus equals my string of J, so current is now AB. If dict contains key, well, there's nothing in here, else dict.add current. So we add AB. And I'm actually gonna make this one. We need to put something in here because the dictionary needs to have 2 elements, but we don't really need the value pair for this key, ever. Okay. So we go through again in this inner loop and we input ABA, and we go through one more time and we input ABAB. Next we start at I equals 1, so the first one is B, the second one is A. We input BA for current, then we input BAB. Awesome. Moving on, we input. So now I is 2. Current is A for J is 3, which means this is the last time we'll do this. Current plus equals yada da da da. So in here we have AB, but we already have AB. Oh, and all of these were 1. So we update this value to be 2. Okay, now we have all of our strings input into our dictionary as keys in the forwards direction, so we'll see if any match in the reverse direction. Okay, so similarly here, I'll make a list. This isn't getting stored into memory anywhere, but I'll make a list for us here so we can see what current is. Okay, so we start at the rightmost. Current is now B. We add on the second from the rightmost, A. Current is now BA. Current is now, the dictionary does contain this key, but the first and the last letter don't match, so a MaxPal is not updated here. Okay, so now current is BAB. Well, that was fast. So let's see. Dict dot does contain the key of current, BAB. Current dot length is greater than or equal to MaxPal dot length. True. Right now MaxPal dot length is 2. Current dot length is 3. And the first element of current matches to the last element of current. Great. So MaxPal gets updated to be BAB. All right, moving on. Current is now BABA. The dict does not does not contain that key, so we move on. And current is A, then current is AB. AB is here, but the first and the last letter aren't the same. Plus it's shorter than MaxPal, so we move on. Next we have ABA. AB. Next we have ABA. Let's see what happens with this one. So, if dict contains key of current, yeah, it does, and current dot length is greater than or equal to MaxPal dot length, and current of 0 matches with the last element. Yeah, MaxPal is now getting updated to be ABA. Cool. And then we have the last value for I is 1, so current is B, then current is BA, and we already have that. That was already compared, but current is now BA, and BA exists here, but the first and last letter don't match, plus it's shorter than the current MaxPal. Anyway, we get down to here. If MaxPal equals AB, no it doesn't, else console.WriteLine, MaxPal. So, the console shows ABA. And there we have it. So an analysis of the time complexity and the space complexity. Space complexity, I already mentioned, is big O of n squared. In worst case, we're inputting n squared elements into this dictionary. I'm not sure what average case would be, but worst case is n squared. Time complexity, we are looping through n squared elements here. We are looping through n squared elements here, but these two nested loops are not nested within these loops. So our time complexity is also big O of n squared, which is an excellent time complexity for this algorithm.